All right. So up here on the test bench, got my resistors, and that's what it looks like when it's at 1 ohm. So I've got the wires coming off of the banks, and that is a 1 ohm load. All right. So 2 ohm, and I'm going to take these two wires off and then connect this one over here. That's a 2 ohm load. 2 ohms. You've got each resistor is 8 ohms. So these two are 4 ohm, 4 ohm parallel together. It is a 2 ohm load. Now, when I want to do like 4 ohm load, then I'll do this right here. And that's a 4 ohm load. And then when I want to do 2 ohm, then I'll just swap them over here. And then when I want to do a 1 ohm load, then I connect the jumpers over here plus here, and then swap them back over, and that's a 1 ohm load. So, same thing that the amp dyno does, the 81. Except I have some manual labor tasks to do that instead of just pushing a button. And I could double my bank and be able to test at a half ohm. I'm not going to do that ever. Never, ever. Before I do that, I'll just buy me an 81. But for all intents and purposes, this setup works just fine. As you can see, I've got one fan over here. I'll end up taking one fan down and put it in a build. I just have to order another fan and put it back in circuit. But I really don't use them unless I'm doing like a high wattage, long time frame test. But for these burp tests, the amp dyno tests, really don't need any external cooling, especially this time of year. It's kind of cool up here. So anyway, that being said, I've got my bank charged up. Right. Let's turn this on. Oh, come on. 15.85. That's connected directly to the 1-aught leads. 15.8 volts. That's what I got the unfurl set to. As you can see, it's on. I can turn it off by this switch. Turn it off and turn it back on. And it's not going to turn back on because the voltage is high enough to where it don't need to turn on. It's got like an automatic sense type of thing. So we'll just leave it as it is. We'll leave it turned on and it'll come on as it needs to. See, there it just now went. See, it just came back on and we're still at 15.84. So anyway, anywho, we're still taped up. Let me put my phone, the camera on a stand, and let's get this test started. Let's unbox it and then test it. All right, let's get the knife out. Now, that's the first time it's been open. First time that it has been open. Now, let's see. This one seems to be packed really well, just like the other full bridge amplifiers. And there's the manual, the owner's manual, and it does have the 18,000 watt amp in here, as you can see, at the 3, 5, 8, 13, and 8,000 watt amp. 4,500 at 4 ohm, 9,000 at 2 ohm, 8,000 at 1 ohm. All right. It says the THD is less than 0.5%. Frequency response 10 to 20K. So it's full range, they are full range amplifiers. So this manual is a lot better than the other manuals with the other amplifiers that I've gotten. Well, except for the 5K, because it's it has the same manual. I do like those 5K full bridge amplifiers. Anybody saying that I'm hating on this Bermans brand, you must not be paying attention. If you keep talking smack on my channel, saying that I'm talking smack about a specific brand or whatever, I'll just block you. I don't care. I don't need your views. I'm just showing what the amps can and cannot do. For the money that you get, those 5Ks, killer deal. Killer freaking deal. Now, if I can get 12,000 to 15,000 watts out of this 18K for under $400, killer deal. Okay? The other amplifiers that blew up, I mean, the 5,000 watt amp that blew up, I mean, that was my fault. I intentionally blew it up. You know, for a 2,000 to 3,000 watt amp for $190. I mean, that was a good deal. And the amplifier looks good. I was going to use it in my own vehicle, but unfortunately, I decided to blow it up. Now, the 2,500 watt amp, it blew up at 1 ohm on its own accord on the test bench, just setting the gains. That one did not do well. I mean, it did not do well. I mean, there's nothing I can say about that. I'm not hating on the brand whatsoever. I love getting equipment that does not cost a lot and that performs well. I will never hate on a brand for being cheap in money, cheap on price. Never, ever. I love brands or no-name brands where you get a lot of performance for your money. Anybody that says otherwise, that says that I'm hating on a brand, you know what? Just get off my channel. I don't want you here. All right, so look, we got a nice bass knob. All right, it does come with, the hex keys, Allen keys, and some screws. The bass knob, it's got the voltage, it's got the power light, clip light, voltage. It's the same one that come with the 5K full bridge. It's got the voltage rectification. I'm glad they put it that way as well, voltage rectification, because that's what you're doing. You're rectifying the voltage. You're not adjusting the voltage. You're rectifying the voltage on the display. So if this is not set properly, then you can reset it here with this potentiometer. That way your voltmeter in the back matches the voltmeter on here, so you can have it up front. That way it's reading the same. All right. So let's get that correct. And then of course you got a long ass cord, phone cable cord, and that's a nice setup for people that use the factory bass knobs on these amplifiers. I do not. I do not use the factory bass knobs. But if I was running just one amplifier in a vehicle, yeah, I would probably use that bass knob. That is a good, that's a good bass knob. I mean, it really is. All right, so we got this in a bag. Let me take this out of the bag, and I'll be right back. I don't want to eat up too much time on the video. All right, so now got it unbagged and everything. So it does come with the some caps on the RCAs, the panel mount or Tiffany style RCAs. Got the metal potentiometers, protect clip and power light. It's got 2 positives and 2 negatives. They're 8-gauge terminal speaker outputs. I wish that that was on the top, but I mean positive, positive, negative, negative. Can't get much easier than that. The inputs are left and right. Left and right, and then you got your bass knob input. And it's got 2 fans here on this end. Now on the other end, the power end. Yep, looks like it got 2 more fans. Now hopefully they got the fans on a push-pull configuration. But you got 2 powers and 2 grounds. They are 1 alt, and it's got the 1 remote terminal instead of 2. So I mean, that's not a deal breaker by any means. I do like the fact that it's the same as all the other full bridge amplifiers out on the market. The positives are together, and then the negatives are opposite ends. It'd be awesome if it was like positive over here with the remote, and the negatives over here by themselves. But they are following suit. Positives in the middle and negatives on the outside. So, and that is the 18,000.1. All right, so let's get to the testing. I'm gonna hook it up. Got the 160 amp hour skip bank. That is the 20 amp hour cells. So that bank is hefty. It's Charged up to 15.8 volts, and it's a hefty bank, more than enough to power this amplifier. It will have voltage drop, probably drop down into the mid to high 14s. So let's test this amplifier out and see what it does at 4 ohm, 2 ohm, and 1 ohm. All right, now we have the amplifier set up, and we're going to put it on over here on 4 ohms. That is 4 ohms. Got the clamp here, 4 ohms, RCA's hooked up, power and ground's hooked up, remote's hooked up to the switch. So now what we're going to do is we're going to turn the deck on. This is the switch for the deck. This is the deck power on the speakers I got, the Pioneer speakers I got down here. That's 4 ohm. Now if you want 2 ohm, 1000 hertz, now that's just deck power, okay? And then this switch right here is the remote. So I'm going to put it on track 1, which is 40 hertz, 0 dB off the DD1 track. I'm going to pause it. I'm going to put it on 50. And it is paused. I've got the oscilloscope hooked up and everything. I'm just going to turn it on. Right, here's your lights. First turn on. Hope it don't blow up. First turn on. All right, it's cycling through. There we go. There we go. Gain is all the way down. Hell yeah. It turned on, no problem. 15.8 volts. 15.83 volts. First turn, let's unpause the track. All right, I think I got it. Yeah, I got set 20 volts. Let's put it on 100 volt setting. And we've got it on 40 hertz. So let's set this is 4 ohm load. You can show 4.7, but let's turn the gain up. This is how I set the gain. There's clipping. Turn it back just a hair. There we go. Clean. Clean. Pause the track. Pause the video. All right, we're back. So I almost forgot to write it down. So 4,500 watts at 4 ohm. That's what we're looking for. It does not specify the voltage or the frequency that they tested it at to come up with these ratings. We are at 40 hertz. I've got maximum on the clamp. And I almost screwed up. I only had one wire clamped. Let's go both wires. One wire clamped. All right, so we've got 2 wires clamped now. See? 2 wires clamped. I only had the 1 wire just a second ago. I almost screwed up. It happens. So we've got both wires clamped. We're looking for 4,500 watts. Here is the clean power, maximum amperage, minimum voltage, starting out at 15.8. Let's go. Well, let's go. Watch the screen on the oscilloscope. All right, we got 2,699 watts. We pulled 284.3 amperes of current. And we dropped down to 15.46 volts. Let me record that. We'll come back with the clipped. Click into clipping. Let me write down everything. I'll be right back. Okay, so that's what we got right there. The efficiency, 61.41% at 4 ohms. 61% efficiency. And there's your calculations. Okay, I can't make this up. All right, so let me reset everything. Be right back from the clipped test. Okay, we got everything set up. We're 4 ohm. 1 click into clipping. 1 click into clipping. Let's see if we can get somewhere close to that 4,500 watts. Let's go. Watch the screen on the oscilloscope. Into clipping. 1 click. All right. 3. That's one of my clamps. I'll have to reset everything here in a minute. 3,179 watts. We pulled 334.3 amperes of current at 15.39 volts on the voltage drop. All right. So let's get set up. Let me record all that data. Let's set up for the 2 ohm clean test. Okay, I've already set the gains for the 2 ohm. Did it the same way I did the 4 ohm test, but there's your efficiency on the 4 ohm clipped test. Right there, I wrote everything down. All right, so now let's do 2 ohms clean. Watch your screen on the oscilloscope, top right hand corner. This is clean, starting off at 15.8 volts. We got maximum clamp, minimum voltage. Let's go. Clean power, rated for 9,000 watts at 2 ohm. All right, that's clean, and we stayed 15.01 volts. So we got 5,638 watts. 5,638 watts at 2 ohms. We pulled 355.8 amps. And there it is. I know the screen flashed up there. But 355.8 amps of current. 15.01 volts. So I'm not sure if that clamp was accurate. We'll find out on the clip test. I'll measure it again and we'll confirm it there. But let me pause the video. We'll write down all the stuff, do the calculations. I'll be right back with the clip test at 2 ohm. Okay, I think we had some kind of malfunction. I'm not sure. I might have had a brain fart and put the clamp on just 1 lead instead of 2 like I tried earlier. We got 105.6% efficiency, and that's physically impossible on that 2 ohm clean run. So let's, and you know, right here's calculations. So let's do the clipped run. We're starting off 15.8 volts. And I've got the clamp on both leads now. Like I said, I might have had a brain fart. Probably did. Probably did. Let's see what the efficiency is on 2 ohm clipped. Here's 1 click into clipping. Watch your oscilloscope screen, top right hand corner for the waveform. Let's go. There's clipped. And we got 6,462 watts. Still showing 355.8 amperes of current. Same current that we pulled before, exactly to the tenths, 355.8. So something's going on with either with my clamp or this amplifier is not liking to be clamped on the input, the inrush current. 14.86 volts. We dropped down to, let's calculate everything, and let me write down all the data. We'll come back with a 1 ohm test. Okay, so we got some crazy numbers. 122% efficiency, and I think I figured it out. So this clamp's got a 600 amp setting and a 1000 amp setting, so I got it on 1000 right now. I had it on a 600 amp setting before, so it probably just crapped out because it didn't know where it was at. So let's do clean. Here's clean. Watch your oscilloscope screen, top right hand corner. Here's clean. Let's go. All right. I didn't have the maximum clamp on there, but it was 1,095, what I see. 1,095 amperes of current. So we're not even going to calculate the efficiency. Let me write down this number and we'll see what the clipped stuff says. Okay, let's go. Clipped power, top right hand screen on the oscilloscope. Let's get 10,000 watts. Come on, man. 11,322 watts clipped. We pulled 1261 amperes of current, and we dropped down to 14 volts flat. Come on, man. Less than 400 bucks, can't beat it.